Tell you what, I think it's about time for us to go to the problem of the day. And here we go. The hypotenuse of a right triangle is 17 inches. A leg is 8 inches. We want to find the length of the other leg. So let's take a look. A picture is worth 1,000 words here. We have a right triangle ready for you guys, folks. So there we have it. Right triangle. That's where we start. And by the way, if we don't have a right triangle, we don't have a hypotenuse, right? Because that's right, no pun intended. But that's where the hypotenuse hangs out. It's the longest of the three sides, so we've got 17 going for us right there. We got a leg of 8, so we're going to put the 17 right there on the hypotenuse. And I'm just looking at this, and somebody said, well, you know the answer, don't you? I said, yeah, that's because it's the problem. But we'll put the 8 right there because that looks like a little bit less than half of that. Certainly this one is not going to be your 8. So we're looking for one that looks to be in the middle. We know 17 is the longest. It's also opposite the right angle. We're also figured out this looks like it's going to be in the middle. We're going to check and we're going to see it's very true. Now, we always, I think anyway, if you've done anything with math, you start thinking right triangles, Pythagorean Theorem. All right, everybody's got that? The infamous a squared plus b squared equals c squared. So let's just go right there. And you know what, just to save us a little bit of work here, I'm going to let this little guy be b. Now, I don't always like to use the letter b there because sometimes it looks like a 6, and it's not looking much more like it's a b, all right? So we got that. Let's go with our a squared plus b squared equals c squared. And a and b can be either of those legs. All right, I just chose to use b since it looks like it's in the middle and it's no big deal there. So we work with this, and let's put some numbers in here. We do know 2 of them. They're important. So put them in there. We've got 8 squared. We have this b squared. And then we've got this 17 squared that we're going to work with. Notice I keep saying squared because it's not times 2. It's to the second power. So we're going to say 8 times 8 gives us 64. Y'all know that. B squared just gives us that. B squared. We do not know what B is. We're looking for that, right? It's our missing piece. And over here, 17 is, I hope you guys know your perfect squares beyond just up through 10. Some of you are going like, I had to hit the calculator for 8 times 8. No! You want to know those by perfect square. You want to know those in your head so you can work with them. So 17 times 17, I'm going to go ahead and tell you today, but remember it for next time. That's going to give us 289, all right? Our deal is, now let's do some subtracting. We're going to subtract 64 from both sides. And we've got b squared equaling, 225. I love 225. You said, why do you love 225, Ernie? Because it's a perfect square. You said, how'd you know that? Because I learned it's a perfect square. It's one of those things, just like your times tables, just like your multiplication facts, it's nice to know your perfect squares. By the way, up through 12 times 12, you already know from 3rd grade. Hope you learned it in 3rd grade. If you didn't, it's a good time to learn it now. All the way, 1 times 1, 2 times 2, 3, all the way up to 12 times 12. Then, think about it. Memorize a few more numbers up to 20 squared. You say, why is that, Ernie? Because, and I'll tell you in just a minute, like I said, it's a perfect square. Let's see what we're going to get. And above all, another reason why you want to know those perfect squares is so you don't have to take 20 seconds to work on a calculator, right? So let's go quickly to the calculator. Find our key here. We're going to go to the second button. And notice that little arrow going up. That means you hit the second button. You did well. Go down straight below that second button, and we're going to find, not log, I went a little too far, x squared right there. That's that little x squared, but dead center pretty much. I mean, it really is right there in the middle. And press it, and it didn't come out x squared, did it? It came out the square root. That's good news. Now we can put our 225 in the little cursor block, and we're going to find out. I said it's 15, by the way. Let's see if I'm right. Of course I'm right on this one, because I know my perfect squares, yes. So there you have it, the square root of 25. That's going to give us b equals 15. Now, I want to mention something else to you, because you guys move on to geometry, you move on to trig, you're going to see these little creatures called Pythagorean triples, right? Triangle families, sometimes they're known. Notice those 3 go together. They're integers. They are a family. We call it the 8, 15, 17 family. So what does that mean? That means if you know 2 of these, the 3rd one's going to fall in place automatically. Things are not going to change because 8 squared plus 15 squared gives you 17 squared. This is 64 plus 225 equaling to 289. There are a lot of other families. There are a lot of other triples. Those are great things to know. Now, we've got some videos of ours way back when that we did some things with Pythagorean triples, but they really make life easier. Saves you time of punching and then having to do square roots. So anytime you see an 8 and a 17, 15 can't be far behind if you're dealing with a right triangle. Same thing if you have 8 and 15, 17 is always going to come back out at the end because the formula stays the same. A squared plus B squared equals C squared. Let me give you another triple. 3, 4, 5, 6, 8, 10, 5, 12, 13. You get the message. But for today's show, it's all about 8, 15, 17. And there's your problem of the day.